Good morning. We are going to be talking about 7.1 and learning about congruent figures. Some examples of congruent figures are the new image and the pre-images for translations, reflections, and rotations. So when we have translations, we are moving this figure from here to here. Well, it's moving down, and then it's going to move left. It's not changing or rotating or reflecting. It's just translation, and it's just going to be moving down. Okay, so let's get back on here. There we go. This one moving, it moves down, and then it moves to the left. So this would just be that translation. Okay, this one, what's happening from this one to this one? Well, it's moving clockwise, and it would be a 90-degree clockwise rotation. This one, first it's looking this way, and now it's flipping over this way, almost a flip. So this would be a reflection, and if we could also say this is going to be a reflection. If I had a coordinate plane here, it's reflecting over this axis, which is our over, okay, write very well on this, sorry, over our y axis. Okay, if I were to flip it over my x, I'm not going to be able to draw this very well. You wouldn't be able to tell it being reflected over your x. Just saying. This one could be a reflection, but it's not. And then this one is a dilation or an enlargement, and that's not what we're going to be talking about. We're going to be talking about congruence and transformation. So congruence, these are all the same. None of them change except for this one, so that's why we're not going to be talking about dilations. Okay, so I can use transformations to create congruent figures, and then I can identify transformations needed to create two congruent figures. So the first thing, composition of transformation, it's just a double transformation. The resulting transformation, when a transformation is applied to a figure and then another transformation is applied to its image. Congruent figures, figures that are the same shape and the same size. So same, congruent, same shape and same size. And two figures are congruent if the second can be obtained from the first through a composition of transformations, whether it's rotation, translation, or reflection. So here, determine if the two figures are congruent by using transformations and explain your reasoning. So first, what do we do? What are we doing from our original here to our new one here? Well, if I reflected over an imaginary vertical line, that would be it's reflected over your your y. So reflected over y axis, and then it's going to be, it would be about what? Here, right? And then it would be translated down and to the left. So if this was reflected over your y axis, and then moved down and to the left. So I would want to say that, yes, it's congruent. It's reflected over the y axis and then translated down and left. Okay, this one. Come on, where's my pen? Ooh, my battery's running out. Okay, so this is my original, and this is my new one. And I'm going to have to do this. What's happening? Well, first, yes, it is congruent. It's reflected over your x-axis. So my imaginary line here, it's reflected over, and that would be by x-axis, and then it's translated. It's reflected here and then translated to the left. Okay. Determine if the two figures are congruent by using transformations and explain your reasoning. So here, if this one was reflected over an imaginary horizontal line, nope, vertical line, this part would be here. So therefore, let's just put it's not congruent because the side box is up 1 on the red one, up on the red figure, but on 2, up 2 on the green. So if you look here, it's up 1 here, and it's up 2 here. So it's not going to be congruent. It has to be the exact same shape, and it's not. This one, if I were to rotate it, it would still wouldn't become the same thing, because here I have the outlining box or whatever, and then I go over one and it would have to be, this one would have to be right here. Okay, so not congruent, the top box on the red figure are 1 apart but 2 apart on the green. So we would want to explain why they are not congruent. Okay, here Ms. Martinez created the logo shown. What transformations did she use if the letter D is the pre-image and the letter P is the image? Well, what would she have to do? Well, first you're going to have to rotate it 180 degrees clockwise, and then you're going to have to translate it up. So that's one way of finding the new image. Or you could reflect it over the x-axis and then reflect over the y-axis and then translate it up. So there's not always the one way to figure out if these two are, there's not only one translation you can do. Okay, this one, what transformations could you be used to make the W, which is the pre-image, or I'm sorry, yep, or the original, and make the letter M with it? Well, you could either reflect it over the over your x-axis, and then you could translate it to the left and down, or you could rotate it 180 degrees clockwise and then translate it down. So this M, this yellow M, is this one being rotated to here. So this one would become here, and then it's rotated down. Or this one, if I reflect it over the X, it would be here, and then I would translate it to the left and down. So how is it becoming right on? How is it getting to become right on top of it? Okay, so yes, it was a quick lesson. Page 513, 1, 3, 7, and 15.